So here we have an inverse trigonometric function, sine inverse of x divided by x. So we'll try to find out the limiting value of this given function when x approaches 0. So let us begin by assuming that sine inverse of x is equals to theta. Now when we take the sine on both sides, so we have sine of sine inverse of x is equals to sine theta. The sine of sine inverse of x is going to give us x. So we have x equals sine of theta. Now we also have to change the limits. So we have when x approaches 0, so that would mean that theta will be equals to sine inverse of 0. Now sine inverse of 0 is also 0, so we say that theta is also going to approach 0. So now our limit will become limit theta approaching 0. So sine inverse of x will be replaced by theta, and x will be equals to sine theta. Now we're going to arrange this, so we have 1 over limit theta approaching 0 sine theta divided by theta. Now we know that the limiting value of sine theta over theta when theta approaches 0 is going to be equals to 1. So we have 1 over 1, which is equals to 1. So this is going to be a standard result that we're going to use. So sine inverse of x over x when x approaches 0, the limiting value is going to be equals to 1. Similarly, we can also find the limiting value of tangent inverse of x over x. So we assume that tangent inverse of x is equals to, let's take it as y. So we'll take the tangent on both sides. That will give us tangent inverse of x is equals to tangent of y. So tangent inverse of x will be x. So we have x equals to tangent of y. Also the limit was going to change. So when x approaches 0, so that implies tangent of y is going to be equals to 0, which implies y is approaching 0. So our limit now becomes limit y changes to y approaches 0. So we have tangent inverse of x, so that will become y divided by x. So x will be tangent of y, which is equals to 1 over limit y approaches 0 tangent of y divided by y, and the limiting value of tangent of y over y when y approaches 0 is 1. So we have the limiting value, which is 1 over 1, that is equals to 1. So this is another standard result that we are going to use whenever we encounter trigonometric inverse trigonometric functions, and we have to determine the limits of such functions. So we'll be doing some problems based on this particular section in the next video.